Hello everyone. Let's see adder experiment in digital design with respect to VLSI lab through the Cadence tool. Now, right click on the desktop, click on new folder. Adder is what I am creating the folder. So open this adder folder, right click, click on open in terminal, and here CSH, enter, then source home install, enter, then nc launch space hyphen new, enter. So this particular nc launch window will come. Click on multiple step and then create cds.lib file. Click on this, then by default create a cds.lib file. cds.lib will be there as a file name. Save it. Third option, don't include any library files. Okay. Okay. So nc launch window will open. So before uh, clicking on this, we need to add a program file. For that, what we do is click on VLSI files. Here constraints files and RC script file is there. Control C, copy this and paste in your adder folder. I have pasted. Now in the next step, in my adder, this thing, go to applications, accessories, and then text editor, and here I need to type my program. So my program I need to type, that is adder program, the Verilog code I need to type. For that, what I will do, I have a typed program here. Control A, Control C, adder, or here adder.v, untitled document. Here I need to paste this adder.v. I need to close, and this one I need to save. I will click on save. So it will ask which path to save. So on the desktop, I'll go back, other location, computer, desktop, then here adder is there. So here I am going to save my program. Then my program name is, let me give it as add1.v. add1.v extension is Verilog file for .v. Save. So now it has come in colored one. So tick reset, tick title, these two default values. Then module, this is the name of the module. Under AC are the inputs, R is the output. So here output declarations. After that, I'm using structural modeling for this particular adder program. So FA is nothing but my instance name. So there are we require 4 full adders for 4-bit parallel adder. Now a single 1-bit full adder I am representing using this particular module, where that module name is capital FA. Now this is my code, a simple full adder code. I'll save it. I'll close this. Then again I'll go to application, accessories. Then I'm going to write a test bench. So text editor. So here test bench I need to copy. So here Control A, Control C. I'll come to the editor. So here I'm going to paste. I'll come to adder, my file. I'll go to applications, accessories again, text editor. So here I'm going to paste the untitled document. So I have pasted. I'll click on save. Desktop, adder is my folder name, and here add1_test. add1_test.v. Save. So earlier one I'll close. So this is my test bench. So these two are the default values, default expressions, and my module name is test_4-bit in my test bench. Inputs and outputs have been declared here, and the input is declared as reg, output is declared as wire here. then instantiation. After that, I'm going to assign my a value, b value over here. 4-bit a value is 0011, 4-bit b value is 0101, and carry input is 0 in the first case. After 10 nanoseconds, I'm changing my a value as 0101, b value as 1110, c value as 1. After 50 nanoseconds, I'm ending my waveform. Now I'm saving this, closing this. Then coming to this NC launch window. Now add one.v, add one underscore test.v is there here. So I'm going to click on vlog. This is to check the errors. So there is no errors here. Add one underscore test.v, select this and then click on vlog. So zero errors again. If there is an errors, it will come in red color and it will prompt a window. Then after this, what I need to do next is I need to extract this work clip, and my test bench is test score 4-bit here. So this I'll click and then I will click on launch elaborator. So after this snapshot, I will extract work clip dot test underscore 4-bit. I'll click on this and I will click on this blue green color button which is launch simulator. So output window will come which clearly shows the waveforms. So here in this window, simulator window, I am maximizing this window, sim vision window, test underscore 4-bit, I am right clicking on this, send to waveform window. So after this, this particular sim vision waveform window will open. So now I am going to run this. Now I got the output. So this is the output. Let me explain this output for you. A input is 3, B input is 5. So this is a 4-bit adder and carry input is 0. 3 plus 5 is 8. Then in the next case, 5 plus E. E is nothing but 14. 14 plus 5. After 14, we have to see in terms of hexadecimal. After E, F. After E, we have to do 5 counts. After E, F 10, 11, 12, 13. So 13 will come. So carry input is 1. 13 plus 1 is 14. So 4 will come in sum and carry out will also will become 1. In the previous case, carry out is 0. In this case, we got carry out as 1. So this will run for 50 nanosecond. After 50 nanosecond, my waveforms will stop. So this is the waveform window. I'll close this waveform window after getting the correct output. Now I'll close even this also NC launch window. Now I'll come to my this thing. So here even this window also I'll close terminal. I'll come to adder. So here right click open in terminal. I'll click on PUD, that is present working directory. Here present working directory path will come. I'll select this control C, or I will do copy itself from the mouse pointer. Then I'll go to adder again. So here I have rc script 1.tcl file. So here I'm going to paste my path. So in the second line I have this. To be precise, in the third line here. So here I'm going to paste my path. Control V. My path is pasted, and here also I need to paste before constraints. Control V. Click on backspace to get into that thing. We can do one thing, line number also we can display line number, so that line numbers I can clearly tell, you can clearly notice. So far what I have done is in the third line I've changed the path, I have changed the search path, and in the 8th line also I have changed the read search path. And after that constraints underscore sdc dot sdc, this has to be as it is, only this much what I have highlighted, this has to be deleted, and we have to give our this thing, our path. Now name of my adder is adder1.v. Let me check by going to adder1. So add1.v, that is my file name. So add1.v. Now basically what I'm doing here, first one is I'm setting the database for my library path. So this is my path, library path, and third line is my file where it is saved, my file path. Then first one, whatever we have written after hash, this is considered as a comment here. Then set db library slow.lib. Slow.lib, fast.lib, there are two kinds of library we have. Slow.lib we are selecting, and then add one.p is the file name. That one I have to read, and that is HDL file. After that, I am going to elaborate this design, and constraints file I have to incorporate. Now I'll explain what is this constraints file, why it is required. 4-bit adder, this is a combination logic circuit which has A, B, C inputs and carry out some outputs. So let me open the constraints file once. Since there is no clock input is required here, we can delete the first 4 lines, and the last lines also we can delete. Only one line is required, that is set input transition 0.12. This constraints is enough. So input transition time I'm giving it as 0.12. By default it will work in nanoseconds, so 0.12 nanoseconds is the transition time. I'm going to save this, close this. So save. So constraints file has been saved, just check once. And then rc script 1.tcl file, this we were discussing. So here generic, mapping and optimization, these are the 3 stages which every execution of the digital program which undergoes. Then here, since I'm doing adder program, I can write here adder underscore netlist, and here adder underscore block.sdc, adder underscore area dot report, that is area report, gate report, power report and timing report I can get. And for getting timing report here, hyphen unconstrained is a keyword what we have to write extra. After that GUI underscore show, that is graphical user interface. So there we are going to get the RTL schematic. Now I'm saving this RTL script file and then I'm closing this. Now what I'm doing next is here I am again opening my C shell. So NC launch is not required. Let me close this. I have to do genus now. Open in terminal, CSH, source. Now here genus. Use the keyboard arrow marks to get the commands. So my genus is loading now. Source space RC script. Just type RC SC, then put a tab mark, then enter. It is going to run everything. So I got the output here. So I am maximizing this window. I'll click on this plus. Then I will click on schematic. So my schematic is ready. It is coming. It is a 4-bit parallel adder. I'm getting this. Now I have to go to my adder folder and then I have to check the reports here. Area report I'm opening. So I'm getting 78.718 nanometer square as area to build this 4-bit parallel adder. Then I'll close this. Area report is done. Then I have to see the power report. Then the total power which is consumed here is 2.36 micro watts. So power is measured in watts. 2.36 microwatts is the power consumption here, which is very less. And then you have to see the timing report also. I'll open this and timing report also will come here. So here we can see the delay in picoseconds, arrival time in picoseconds, everything we can see here. Thank you.